Hello everyone, so my name is Pavel. This is the first class of our JetBrains coding club, and you probably know me as Pashka on Codeforces. You probably saw my lectures. So the main thing I do, I read lectures about algorithms, data structures. So I have some lectures on YouTube, some lectures on Codeforces. That's the main thing I do. This club will be a little bit different, so we will not focus on algorithms and data structures. We will focus on problem solving. So the idea of this class is to teach you how to actually solve competitive programming problems. Because I think that nobody had lectures of this type, and I'm trying to do this. I'm also not sure how to do this actually, but we will try. Because what's the reason? Because many people ask me on Codeforces or in life, so anywhere, ask me how can I be better in competitive programming, and that's a good question. And I usually just answer, okay, you need to solve a lot of problems. You need to, when you solve many problems, you get some tricks and you learn some approaches how to do this. But that's okay. So it's, if you just do it by yourself, it's maybe not very productive, because you just try solve problem, you fail, okay, you try again, you fail again. At some point, it's kind of it doesn't feel very productive. So what we'll try to do here is every week we'll have a contest, and after a week we'll have a session like this, and I'll try to explain you, not only explain you the solutions, that's boring. So if you just explain you the solutions, you will not learn anything. I'll try to give you some ideas how you can approach actually to give solution, what you should pay attention on, and what steps you make to get the correct solution. That's the planning, at least. We'll see how it works. Okay. So what contest do we solve? That's a good question. So to prepare the contest, I usually, before I started this course, I prepared the solution by just hand-picking some interesting problems. So I just looked at Codeforces, find some interesting problems, not only in Codeforces, look at some different contests, find the most interesting problems and pack the contest out of the interesting problems. And it turns out that it's not really helpful, because in real contest, you will not always have the most interesting problems. And you need to learn not only how to solve interesting problems, but how to solve all problems of all different types. So some of them may be not that interesting. So the contest I picked today, and I plan to do it in the future, is just some pack of random problems from Codeforces. So I especially wrote a script that picks some random problem of desired difficulty. So it's looked at the difficulty on Codeforces and just picked some random problems. I then adjust it a little, because again, difficulty on Codeforces is not that accurate sometimes. And then I just create the contest out of these random problems. And this will ensure that I'm not biased. So we'll try to learn how to solve all types of different problems that you can face in the competitions. Today, for example, we have very math-heavy problems. So we have a lot of math-heavy problems in this contest. And that's actually that will happen in future, I believe, because on Codeforce there are a lot of math focused problems. Okay, I believe this is all introduction, so let's look at our contest. So what we have today. So the first problem, let's see. So all the problems of this contest are not easy problems. So we don't have any easy problem in this contest. All problems are so they are not that hard, the first problems, for example, but they're especially not easy. So even the first problem, you need to do a lot of steps to solve this problem. So what do I mean? So what do you do when you solve the problem? No, first of all, you need to read the statement. That's a nice first step. And you need to understand what's going on here. And sometimes it's actually the most important step and most hard step in the most difficult step in solving the problem is just to read the statement and understand what's going on. Sometimes problem authors just tell you what to do. It's a very rare situation, actually. Usually, problem authors, they prepare the problem in such a way that you need to read the statement, usually some long statement with some boring details, and understand what's going on, and produce, understand what's going on, understand what is the question, and produce the answer to this question. And this is the most intellectual part of the problem solving. So let's see. So what's going up in the first problem? In the first problem, we have some strange game, and that's a quite popular situation in problem statements. So we have some game between two players, and we need to decide who will win in this game. Then you need to understand what are the rules of this game. So you read the statement and try to understand what are the rules of this game. So in my case, it's very simple. I have some buttons. Every person press some button on his turn. We can press the same button multiple times, and if you cannot make the turn, you lose. So first, then what you do when you think about this game. So first of all, you think, okay, if I just have buttons, I can press them. So what will happen? So again, so let's make it choo-choo. So what will happen? Okay, so you have some buttons, and two persons are playing. So first player press the button. Now I can't press this button anymore. Then second player, then first player, then second player, then first player. Now it's second player's move. Second player cannot turn it. Can't push any button because all the buttons are already pressed. So the second player loses. So the first player moves here, second, first, and now second player loses. Yeah. Immediately you can see from this situation, then if you have a situation like this in this game, the result of the game only depends on the parity of the number of buttons. Yeah. So if you have like odd number of buttons like here, then the first player wins. If you have even number of buttons, then the second player wins. Okay. Okay. That's like the first intuition you get from the problem statement. Now you see that you actually have three types of buttons. You have A plus B plus C. You have three types of buttons. So the situation is a little bit more complicated. So you have some A buttons only pressed by the first player and B buttons only pressed by the second player. And we have some C buttons that can be pressed by both players. So we have some, again, we have set like of A buttons here and set of B buttons here and set of C buttons in the middle here. And the first player can press all these buttons, say A, and the second player can press all these buttons, say B. Yeah. And now we have the same game. Now, what you do when you try to analyze the game? You first try to play this game manually and see what's going on. So you see, okay, so imagine you are one of the players, like the first player. Imagine you are the first player, and you have a situation like this. So you think, what should I do in this situation? So I have like, so if I have buttons to press, so if A is greater than 0 and C is greater than 0, so if I can press at least some button, I need to press some button. Yeah. So what button? So what options do I have? I can press one of these buttons of type A, or I can press one of these buttons of type C. And then you think, what is the most optimal move? So I have two types of moves. And okay, if you think about a little about the situation, so you think, okay, so every time I press the button, I decrease number of moves I can do in the future. But if I press button here from C, I also decrease by 1 the number of moves of my opponent. So if I press one button here, I decrease number of buttons that I can push. But if I press button here, I decrease number of buttons that both I can push and my opponent can push. So these moves look always better than this move. So if C is greater than 0, so if I have at least one button in this set, I can always press one of button here and it will be always optimal. That's all. So if this set is empty, then I only can push one of the buttons here. But that's what so if you don't have any options, you make this move. Okay, starting from this, you can actually create some solution. So what you have solution? So first player moves like this. So if C is greater than 0, then I press one of the buttons here, then I decrease C by 1. I use some strange language, doesn't matter. So it's some pseudo language. And if not, if let's say A is greater than 0, then I press one of these buttons. and if not, then first player cannot make any moves, and then first player loses. And the second player has the same strategy. For the second player, I press one of the buttons in the middle if I can. If I don't, I press one of the buttons from my set. If I can, then second player loses. Good. Now, we can immediately make a program out of this, but it will... Sorry. Okay. If you want to ask any questions, just ask. Okay. So, if don't, just no. Okay. From this, you immediately can make a program. So if you can just simulate the situation. Let me just do it. Okay, it'll be faster. Just do it. So what you can do, you can move it here. So you can read A, B, C. And just make move by move. So you can just again you make move of the first. Let's say true. So you make move of the first player, then move of the second player, and so on. So when you make move of the first player, say if C greater than 0, just like explained. So you can see minus minus. Else if A greater than 0, you make A minus minus. And if not, then the first player loses. What I need to put this a second now. Second. Or something like this. And then the same for the second player. Yeah. Now let's check it works actually. Second player moves if B. I just explained it in all details so you see how do I think when I solve the problems. What? No, I didn't plan to do it. First, second. Okay, it works. So it works, but it is too slow. Okay. Now that's a good step again. When you solve the problem, the good step is just to imagine some solution. So okay, again, at least this solution solves the problem. So it does what you need. The only problem, the solution is very slow because every time I do only one step, and I may have up to 10 power 9 buttons. Yeah. So 10 power 9 operations is too much. So I need just to make the same solution, but to make it fast. Okay, let's move back to the whiteboard. So how to do the same but fast? No, let's see. So what happens? Like again, now we know how the game looks like. We know how the strategy looks like. So we just need to make it faster. We need to faster understand who will win if we apply this strategy. Well, we see. So what will go on again? We have some set A. We have some set B. And we have some set C. So what will happen when we apply this strategy? First, both players will press buttons from this set C. Yeah. So we have like the first player, second player. So first player press button from set C, second player, first player, second player, first player, second player. Yeah. So when this process will over, it will be over when we have no more buttons from the set C. Yeah. So if we have even number of buttons from set C, then we will finish all the buttons from set C and we start again from player one. Yeah. So player one again has the first turn. So now the player one will press button A, B, and so on. So if set C is even, we apply this strategy. Yeah. So we just keep all the buttons from set C and we start from the same point, but only we have buttons of A and B. And if we have buttons from A and B, we just look at the number of the buttons. If number of buttons in set B is greater or equal to number of buttons in set A, then first player will win. Or second player will win. Yeah. First player will win if the number of A's is let's say so. So the first player only wins if the number of buttons in set A is strictly greater than the number of buttons in set B. Let's just implement it like I said. I will implement exactly like I said. So what I'm doing here. So I see if number C is even, then I look. So I skip all the buttons from set C. Then I look at buttons of sets A and B. So I see if number of buttons in set A is greater than B, then the first player will win. Again, first second. Okay, we solved the whole case. So in this case, we solved the whole problem. Now we just need to do the same if number of C is odd. So if number C is odd, then I have the same situation. I have put C, 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 C. But I just stop here. Yeah. In this situation, I start doing the same thing, but I start from the second player. So this situation stop, and then I start from the second player. It's second player's turn when I finished all the set C. So I start from here. Okay, B and then A, then B and then A. So I have symmetrical situation, but now the second player is moves first. Yeah. So you have the same situation, but the second player is now the first player. Yeah. So you do the same thing. You say boom, 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 boom. Here the second player wins if B is strictly greater than A. Yeah. So if A is greater or equal than B, then first player moves. And actually the only difference between these two options is when A equals to B. That's all. That's the whole solution. Let me just again. Boom, 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 boom. Okay, that's that. Okay, maybe I'm not sure if I spent too much time explaining this solution. Yes. Okay. Hope it was not too boring. Well, in another advice, what you need to do, first you need to read not only the problem statement, but you also need to read this explanation. Usually, especially in code forces, authors give explanation for the examples at least. So for these examples, they explain you what's going on actually. Like here they have a long explanation about what's going on in the third case. So in this case 1, 2, 3, they just give you a big explanation of what's going on. So when you're not sure what's going on, you can always read this explanation, yeah, and make sure that it's actually correlate to what you think about this problem. Yeah. So if you read this explanation and it doesn't make any sense, it usually means that you just didn't understand the problem correctly. You go back, read the problem statement again, try to understand it again. Let's move to problem B. So problem B is actually interesting. So what's happening in problem B? Again, you have some strange situation. You need to understand what's going on and figure out how to solve the problem. So what you do in this problem? Again, now I suppose you read the problem, and I'll go a little bit faster. So what we do in problem B? So we look at this. This is the problem. Contest today is very math heavy, so we need a lot of problems involves a lot of math. So what we need in this problem? You just go and try to think what's going on in this problem. Yeah. So what's going on in this problem? I try to apply the operation like this. I take two numbers. So I have an array. I take two numbers from this array. Let's say x and y, and replace them both with the difference. So let's say x greater than y. So I replace both these numbers to x minus y and x minus y. Yep. And I need to do it in such a way that my sum of all the numbers only is not decreasing. Yeah. So let's look at the sum of all numbers before operation and after operation. No, before operation I have x plus y, and after operation I have x minus y plus x minus y. No, so you have 2x minus 2y. Yeah. And I need this number to be greater or equal to this number. Less or equal. Greater or equal. Yes. Yes, greater or equal. Yeah, great. Good. So let's look at, so now we have, again, we have some simple linear equation. So how do we solve a linear equation? We put everything connecting to x to one side, everything connected to y to another side. Yeah? So in this case, it's really simple. So I put x, let's say, put x to the right. So I have 2x minus x. I put this x to the right. So I have x here. Yeah. Put this 2y to the left. So I have y plus 2y. So I have 3y to the left. And that's all. And now you have some simple inequation that you need to satisfy. So to satisfy these constraints, you just need, for every pair of numbers such that x is greater than y, you need x be greater or equal than 3 of y. That's all. And now you can understand how shouldn't we have this? Yeah, that's exactly what I read. 2x minus 2y. No, less or equal. No. I need to find an array that this sum is not decreasing. Yeah. So after operation, sum should not decrease. So yeah. Again, this long statement. So one people say that it should be decreasing. Yes, so it's not decreasing. So it would be not decreasing. Okay. Now, how to build array when you have this property? So every bigger number is at least 3 times bigger than another number. No, it's simple. You be like 1, 3, then 9, 27. So every next number should be at least 3 times bigger than the previous number, and so on. So every next number is 3 times bigger than previous number. And so if you build array like this, you have actually an answer. Okay? But then you look at this again. You look create a problem statement and saying that sometimes answer is no. Yeah, like this here. So you also may think why the answer is no. So how can it happen? I can always build the array with this property if I just assign each number to corresponding power of 3. And you think, okay, I have another property here. So again, so all the numbers should be not greater than 10 power 9. So if n is too large, then the corresponding power of n. So again, so what numbers I put here? I put numbers 3 power 0, 3 power 1, and so on. The last will be 3 power n minus 1. Yeah. If this number is greater than 10 power 9, then it's impossible. That's all. So that's the whole problem. Again, what you're doing, you try to analyze what's going on in the statement. You read the problem statement to try to reformulate the problem property using some actually very simple mathematical operations. So again, you have linear equation. You just look at this linear equation and try to solve it. So and you get this very simple solution. And now when you have this very simple property, you try to build the array that satisfies this very simple property. So again, you take property from the problem statement, simplify it, then use this simplified property to build the result. That's all. That's how we solve the problem like this.
Sir, can you please explain how did we get that equation again, please?
Which one? This one. Again, this equation is just equation from the problem statement. So again, you read the problem statement and see what's going on. So the problem statement tells us, again, what we can read from this problem statement. It said the following. So I have my array. Again, let's read it together. So what we're doing in one operation, we pick two indices, I and j. Yeah. We have operation AI, or we have element AI, element AJ. And what we do, we replace both these elements with difference ups of AI minus AJ here and AI minus AJ here. That's the operation we make. Yes. And we need to build array when this operation do not decrease the total sum of all elements. It's written. It's all written here. You just need to read it carefully. Yeah, the skill of reading the problem statement is actually very important. So sometimes problem statement is overcomplicated with some strange details. So they introduce some strange characters to the problem statement. They introduce some strange operations. So it's sometimes it is the most difficult part of the problem of solving problem is just reading the statement. So again, this is what actually they tell you here. We need to say, so we need to have the following. We need to follow so AI plus so after operation we have sum increased by AI minus AJ twice should be greater or equal than AI plus AJ. And now I just replace one of them with X, another with Y, so such that bigger one with X, smaller one with Y. So one of them is bigger, another is smaller. So I say bigger one is X, smaller one is Y. And I have 2X minus Y is greater or equal than X plus Y. Okay, try to just simplify the property as much as you can. And after you have the most simple property, you just build the array that satisfies it. Good. Okay, that's the second problem. Let's move next. Problem C. Okay, problem C is not math heavy. Problem C is actually just implementation problem. It also happens. Sometimes you just need to implement what's going on in the problem statement. Again, you just read the problem statement, understand what's going on, and just implement what's going on. So it's very specifically for this problem, A and B are very small. So you can actually solve the same problem for big values of A and B, but you do not need to do it here. You can just do the following. You can iterate all numbers from A to B, and for each number, calculate the number of indicators. Yeah. So you make loop over all numbers from A to B. For each number, you split it into digits. For each digit, you know how many segments you have. You sum all this number of segments, and in the end, you have your result. So nothing math specific having in this problem, just simple implementation. You need to read the statement, understand what's going on, implement it. Can you tell me your? We can definitely find the bug in your solution. Just tell me your handle, please. Is it the same? No. I remember you were somewhere here. Yeah. Okay, let's get. Okay, I think I see the problem, but again, first of all, let's say so. First of all, you don't need this part. So it's not bad. It's just you just don't need it. Now see, there are not that many suspicious things in this program. Okay, so you have string, you iterate over all numbers here. So this looks fine. Let's copy this. We'll spend some time. I'm not in a hurry, so we will spend as much time as we need. Okay, that's the plan. Let's see. Let's move back. Okay. Looks actually very nice. So let me remove this. So you don't need this part. I'll just remove it. It doesn't just do anything. So, let's look at this problem. Let's look at this S. So this S should contain all the digits of all the numbers. So just output this S and see that we calculated correctly. 10, 15 look fine. Well, it looks fine. So I have 10, 11, 12. Looks very nice. Okay. So this part looks very correct. This part. So what I'm doing here, I iterate for all digits. For each digit, I take the corresponding digit, subtract 0, so I have from character. So I get from character of digit to actually to the number and add number from this magical array. Also look very nice. So the only suspicious part of this problem is actually this magical array. Yeah. Now, what you need to do is just every time you have magical array like this that you just created by hand, it may be wrong because you create this array not automatically. You just do it by hand, and when you do something by hand, sometimes you make mistakes. So you just go to this array and check it again manually. Can you spot any problem in this array? Okay, let's do it one by one. Let's do it together. First number have 6 segments. Good. This have 2 segments. This have 5 segments. Good. This is also have 5 segments. Nice. Here I have 1, 2, 3, 4 segments. Look fine. Here I have 5 segments. Look fine. Here I have 6 segments. Look fine. Here I have 3 segments. Look fine. Almost nice. Here. Yeah. Here again, you need to be really careful when you do something like this. So number of segments here is actually 7. Yes, it's like 4 plus 3 is 7. So this number must be 7, and this number must be 6. Yeah, no, it's even called 7 segment indicator. Yes, I believe that's the whole problem of your solution. So it's actually almost correct. You just need to pay a little bit more attention to such details. Yeah. Again, if you're relatively new to competitive programming, it happens a lot. It's not a big problem. So just next time when you do it, you just pay a little bit more attention. So it's okay. It will succeed. I trust it. Good. Yes, silly mistakes will happen all the time. So when you have more experience, you make less silly mistakes. Then you will have really interesting mistakes at some point. That will happen. Let's go. Problem D. What we have in problem D? Again, we have some math-heavy problem. We have some array. We have some strange operation. We need to understand what will happen when we apply this operation. Again, what you usually do when you solve problems like this, you just play a little with these numbers and see what's going on. So, for example, if I have just 2 numbers, like numbers A and B, what will happen? So, if I have just 2 numbers, I pick one of them. No, let's just pick numbers from left to right for simplicity. So, I pick the first number, I remove it from array, and second number became B minus A. Yeah, so this will be the result. Now, if you have 3 numbers A, B, and C, so you first remove number A, so you have B minus A and C minus A. Then you remove B minus A, so you have C minus A minus B minus A. It is the same as C minus B. Then you try 4 numbers, A, B, C, D. You stop when you feel like you understand something. Okay, so you just play with small tests until you understand what's going on. Sometimes it never happens. It also may happen. So you stop doing it and try something else. But again, sometimes it just works by playing with small tests and trying to understand what's going on. So if you have 4 numbers, I have A, B, C, D. So you remove A, you have B minus A, C minus A, D minus A. Then you remove B minus A. So you subtract it from here, you have B, C minus B. Again, C minus A minus B minus A, C minus B. D minus A minus B minus A, it will be again D minus B. And you're like, okay, I had similar situation here. Yeah. So you feel kind of like you understand what's going on. So when you remove this, you have D minus B minus C minus B, so you have D minus C. And you're like, okay, I tried some small tests. And every time the final result is just difference of last 2 numbers. Maybe it's always the case. And here, okay, here's the difference between math competitions and programming competitions. In math competitions, when you feel something like this, that you understand what's going on, you need to prove it. In programming competitions, you actually don't need to prove it. You can just try, submit, and see if it works. Sometimes it may fail. So sometimes it's okay. When you just believe something should work and you try and it doesn't work and you're not sure what to do next. Sometimes it works, like in this case. So again, what is my hypothesis? My hypothesis is that if I take an array and I apply the separation from left to right, and last 2 elements are x and y, then the result will be y minus x. Okay, then again, if you're a good mathematician, and it's actually, my another advice is to pay more attention to math competitions. So if you feel like you are not very good in solving problems like this, maybe you need to solve more math problems. Yeah, so because in math problems, they actually focus on situations like this. Now, if you figure out all this stuff, so you figure out, you stopped here, yeah? So you play it with operation and you figure out that the result of operation is y minus x. Now let's understand the problem, what we actually need to do. So we need to do the following. We have array A. We need to apply the separation in some order, not from left to right, in some random order. Yeah, so we decide in which order. And we need this number to be exactly k. What will change if we apply operation not from left to right, but in some random order? Actually, nothing will change. So we can just rearrange the numbers in such a way that they apply operation from left to right. So we need to check if it is possible arrange the numbers in such a way that difference of last 2 elements is k. That's all. So you need to check if it is possible to arrange numbers in such a way that difference of last 2 numbers is k. No, it's only possible if you have 2 numbers with difference equal to k. So that's all. That's what you need to do. You need to check if in the array I have 2 numbers with difference equal to k. Now problem looks much more easy. Yeah. So again, you start with problems like this. You have some strange operation. You need to do something. You need to have some. It looks very complicated. But when you analyze it, so after every step of an analysis, you have more simple and simple problem. And now I have very simple problem. I need to check if array contains 2 elements with difference of k. That's all. Okay, how to solve this problem? No, there are many ways to solve problem. Okay, if you if you stop at this point and you don't know how to solve how to find 2 numbers with difference k, that's actually means you need to solve more programming problems. So now we have especially programming problems. So we start by solving some math problem. Now we have programming problem. And there are many ways to solve this problem. For example, what can we do? We can sort all the numbers. And then we need to find x and y such that y minus x equals to k. We can do it using 2 pointers method. We can do it using binary search. So we can, again, you can fix x, and then y should be equal x plus k. So we can iterate row number x and look for number y, which is equal to x plus k. So we can do it using 2 pointers. We can use it using binary search. Or we can use some simple data structures, like in C++ you have set, for example. So you can take all the numbers, put them in a set, or in Python you have a specific, any type of set you have, ordered set, unordered set, any type of set will work. So you just, so you iterate for all number x, and then for each number, so yeah, pseudocode, okay? So you check all numbers from your array A and check if A contains number x plus k, then you're done, yeah? Yes. Something like this. So you need any data structure that allows you to look in the set and see if your set contains the element. You can use any type of set. Again, you can hash tables. You can use binary search trees like in C++, or anything will work. If you don't know how to use any data structure, that's a good time to start using it. For example, it depends on what programming language do you use. If you use C++, learn how to use simple sets. So we use set of int. If you use Python, they just use set. Does anybody use anything besides C++ and Python? I don't know. So if you use any other strange language, I believe now any modern language has at least some type of set, so you just can take it and use it. If you don't, you can use you can learn how to implement hash table, for example. I have a lecture about this. You can watch it. Okay, another math-heavy problem. So in this problem, what you need to do, you need to understand again. So again, I will repeat it several times again. So you need to read the statement, understand what's going on. Strange things going on in this problem. So you have some coins. You make the bets. If you win, you received y multiplied by k coins. Yeah. So you get back your y coins and get these more coins. And if you lose, you just lose the y. And the only condition or only constraint you know is that you cannot lose more than x time in a row. Okay. So the question is if it's possible to win infinite number of coins. No, first thing again, when you play a little with this. With these models, so you try to play this game and see what's going on. What you can see. So again, question is really strange. So question is if it's possible to get infinite number of coins. Infinity is scary. So it's try to get infinite number of coins. So when you think about infinity, you may get strange thoughts. So instead of thinking about infinities, let's think about finite numbers. Okay, so especially so we start with n coins. So we start with n coins. N, what is x? Number of times what is where is n? So I have k, x, and a. Initial number of coins is a. What is n? For any integer n. So initially I have a coins. So initially you have a coins. Yeah. So instead of trying to get infinite number of coins, let's try to have a plus 1 coins. If I can have a plus 1 coins, then I can save this one coin, put it in the pocket, and then do the same strategy again. And again, a plus 1 coins, put 1 coin to the pocket and continue. Okay, so in order to get an infinite number of coins, you just need to be able to get from a to a plus 1. That's all. Okay, now we get rid of all infinities. So we have very simple finite problem. So we need to check if it's possible to get from a to a plus 1 using this strategy. Good. The problem is we don't. So we make bets. We don't know when we win. So again, we make a bet, when we make another bet, another bet, another bet. So in the first, so in the worst case, we need to make x plus 1 bets until we finally win. So yeah, so we can't lose more than x, right? Yeah. So we make lose, 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 and then finally win. Yeah. So our plan is to get A+1 coins. So, let's see the first time when we win. When we win, we need to get at least A+1 coins. Yeah. So again, imagine situation: you lose, lose, and then you win. If at this point you have less than A+1 coins, then you just have the same situation as before. So if here you have greater than A coins, then you have not great. Your situation is not better than in the beginning. Yeah. So when the first time you win, you need to have at least A+1 coins. If you have less than A+1 coins, then you move from your initial situation to some situation which is not better. Doesn't make any sense. Yeah. Okay. Hope this. Again, it's not easy problem. So you need to play a lot with this game to understand what's actually happening. But when you understand what's actually happening, you move closer to the solution. Yeah. So again, first of all, we get rid of infinities. So we don't need to get infinite number of coins. We need to get A+1 coins. Then we limit ourselves only to the first sequence of moves before the first win. So we will lose, win. When we first time win, we need to get at least A+1 coins. Nice. Now we can win in any position in the first x+1 turn. So any of these x+1 turns may be winning turn. So we need to make a bets in such a way that if we win it in any position here, we get at least A+1 coins. Good. Now just play the game. So you have A coins. Yeah. So I make bet of size y. So if I win, I get A plus y k minus 1 coins. Yeah. I need this. Okay. No. Let's keep like this. I need this to be at least A+1. From this, you find what is the minimal number of y. Why you pick the minimal number of y? No, because you want get. I need to win in any of these moves. So it may be that I lose, and I want to lose as minimal money as possible. Yeah. So you pick the minimal bet you can make in such a way that if you win, you get at least A+1 coins. Again, you need to make sure that if you win, you have A+1 coins at least. Because if not, you will get in the worse position than before. From all these possible bets, you pick the minimal possible bet. Because if you lose, you want to have, again, you have a maximal possible position. That's all. So from this, you find the value of y. So value of y should be greater or equal, again, 1 plus 1, and y divided by k minus 1. Then you have the new position phrase. So now you have, let's say A is niet proportional. Now let's say the current number of coins is, let's say, we don't have C. Let's say C. C is current number of coins. So so we need to find y. So we need to minimal possible. We need to find the minimal possible bet that gives us at least A+1 coins if we win. And we can get from this, so it should be oracle A+1 minus C divided by k minus 1. Yeah? And since y is integer, we just say that minimal possible y is we need to round it up to A+1 minus C divided by k minus 1. So this is the minimal possible bet you can make. Can just no. First bet, yes, you're right. The first bet may be 1 coin. So first time when you make third bet, but then you have less coin. When this C is less than A, you actually need to you have to make big bets. So if you win, you got you start with position A. So if you lose, you have less and less coins. So you need, so if you eventually win, you need to go to back to this place, to A+1. Yeah. So after you lose several times, you need to make a big bet. So if you win, you go to A+1. And that's all. And now, what is the condition when it's snow? When the answer is no, it means I just don't have enough coins in the middle. So you try to make this x-1 terms. If the number of coins goes to 0, yeah, it means you lost. So you lost all your coins. You can't make any more bets. That's all. Yes. Again, we can't assume. So you think that you assume only the worst scenario when we lose all the x times and then eventually win. But again, you don't need to consider only this now. So when you lose x times and then win here. So if you know it will happen like this, then you can place. Can you place 0 bet? No, you can. No, you can. You can place 1 coin each time. So you lose as small amount of money as possible and when win here. Problem is you don't know when you will win. So when you make every bet, you need to be ready that this is your winning move. So now you will get an edge. So your move should be such that if you win, you will get at least A+1 coins. If you win, yes, yeah, but you don't know that this, so you don't know if here you will win or not. So you may win, for example, here, and here again start your losing streak. So if you win before this x+1 turn, so if you win here, then the next losing sequence started. Yeah, so you don't know again when you will win. Good. Actually, a lot of people solve this problem. It's actually good. So let's check some solutions. Look at some good solutions. Let's check someone in the top of. Yeah, very short program actually. So again, solution itself, programming part of the solution is very easy. The tricky part is just all this math part of the solution. So you need to understand what's going on in the math problem. Then you solve all this math part. Then the programming part is actually easy. Yeah. So again, you check what need bet. Okay, I believe in this solution, bet is the amount I've already lost, and need is the amount I need to bet. Okay. So I had initially I have A. So I need to win everything I lost by now plus 1 at least. Yes. So I need to bet this amount of money. Yes. And if I lose, I add this amount to my total loss. So bet is my total amount of money I lost. If I lost more than A, it means game over. Y is greater but not greater equal. Because I check it here. Also happen. Okay. No, okay, also possible. You can do this like another iteration of this loop. You make x1 of my, okay, you can just make another iteration of this loop and check if you lost. Okay, you just make this last iteration separately in the end. Okay, let's try somebody else, like somebody here. Okay, let's plus 4. Okay, you tried actually a lot. Yeah, exactly. Well, it's essentially what I'm talking about. So you have x iteration, you have less circle. So you make one more iteration. Every time you calculate how much you need to bet. Yes, to cover all your losses plus 1. Yes, add it to the lost if. What? Okay, that's the strange condition. A minus lost multiplied by k. If it's impossible to win this amount, what? Looks a bit complicated. Okay, yeah, I believe you can simplify this, but again, okay. Good. Now go problem F. Another math-heavy problem. Another math-heavy problem. Again, we have a very math-heavy contest today. Again, something strange happening in this. So we have Pythagorean triple for some reason. We have some strange Vasya who do some strange stuff. We have some strange formula coming out of nowhere. Okay. So we just read this and just carefully understand what's going on. It may be some nonsense. Some nonsense may happen in this problem. So you just try to get this problem, extract the important part and just discard everything which is not important. Like spice is not important, everything is not important. Important thing is this formula and what we actually do. So what we actually need to do. And we need to do the following thing. We need to find the triples. So they are Pythagorean triples, and also they satisfy this formula. That's all. So again, you try to read the statement, try to discard everything which is not important, and so only the pure mathematical part remains. Sometimes it's hard to do, like here, but when you do it, you have the again, not simple, but simply formulated mathematical problem. So what we have in here, we need to find number of triples ABC. So all numbers not greater than n. Okay, a list, so sorted. Okay. So this triple is Pythagorean triples. It just means c square equal to a square plus b square. So if you don't know what is Pythagorean triple, I believe they explain it here. Yeah, no. Okay, they're not explained here, but I believe you can Google it. At least in Codeforce competition. So in some competitions they don't allow you to Google. I believe they should explain what is Pythagorean triple in case you don't know it. But Pythagorean triple is like this. So we need this, and we need this. Okay, and we need now we just do math. So we have two equations with three variables. Let's get rid of one of them. For example, of c. So we have c here. Let's compare. So we will calculate square of the second equation and add it here. So we have a square plus b square equals to a square plus b square. Why I'm doing it in this way? No, because I feel like it may be good. Again, after some time spending of solving math problems, you have some kind of intuition of which approach will work, which approach will not work. In this case, for example, I see that here I have b square, so in the end I will have b square here, and here I have b square. So they kind of eliminate, and something else, something good will happen. Yeah. So again, maybe not, but I will just try. So I just get rid of c. So now I have two variables. Two variables better than three variables. Yeah. So I have it like this. So we have so we have a power 4 plus 2a square b square equals to a square plus b square. I forgot b square. Just b, okay. Plus b square. Thank you.
Square minus b. It's a square minus b
minus
equals
b
square.
Okay, minus b. Okay, makes sense to have minus. Thank you. Equals to a square plus b square. So we can eliminate this b square. That's good. Again, I kind of foreseen it before. So now I have everything is divisible by a square. So I can divide everything by a square. So I will have a square minus to b equals 1. Yeah. Again, you start from what you're given in the problem, then try to use math to simplify it. Okay, I simplified, I get this. This part looks interesting. So what's happening here? I have a square equals 2b plus 1. That's all. That's all. Now let's solve the problem. So what we have in this problem? I need to find number of triples such that a square should be equal to 2b plus 1. Now, if a square equals to 2b plus 1, then what are possible ways of, so let's rewrite it like this. So no, I already see what's going on, but let's derive b from this. So b should be equal to a square minus 1 divided by 2. Now, a is integer. It means that not that many possible ways to calculate this b. No, let's just what's the easiest way to do it? Let me think. What is the easiest way to do it? Well, again, let's finish all these formulas. So if you do it like this, and you can calculate c actually from this. So c is equal a square minus b. So from this formula, you can get that c equals to a square minus b. So a square minus this, it will be just a square plus 1. No. Yes. Yeah, makes sense. So what we need to calculate? We need to calculate triples. These triples always look like this. A equals a, b equals to a square minus 1 divided by 2, and c equals to a square plus 1 divided by 2. Yeah. So we just, again, you just apply normal math reasoning. Just do something, have equations, simplify them, try to eliminate all the variables what you can, and then you end up with some, again, very simple equations. Sometimes it happens, sometimes it's not. So in this case, you have very simple equations in the end. And now the problem is like this. I need to find number of triples like this, such that all these numbers are not greater than n. Good. Now, first of all these numbers must be integers. So to calculate this, so let's look at number a. So these numbers are integers if a is odd. So a must be odd. Yeah. And a must be at least 3, I believe. Yeah. Yeah, I believe for any a at least 3 and odd, this formula should work. For example, I have 3, then I have 3 square minus 1, and 3 square plus 1 over 2. So here I have 9 minus 1, 4, here I have 5. Yeah. Or you have 5. Here we have 5 square minus 1 over 2, it's 25, 24, 12. And here I have, no, it's plus 1 again, it's 13. So 5, 12, 13, also Pythagorean triple. Looks promising, yeah? So again, now I just need to calculate number of triples, so all these numbers not greater than n. So to check all these numbers are not greater than n, I just need to check the last number, because this is the biggest number. Yeah? So I need to find number of a, so they are odd, at least 3, and a square plus 1 over 2 should be not greater than n. Yeah. Again, try to simplify this thing. You need to look at number a. You need to find the constraint for number a. So you put this 2 to the right, minus 1, so you say a square is not greater than 2n minus 1. Great round. I have at least 3. It's the same thing. Boom. That's all. So this is the problem we need to solve. Let me break this down. So I need to find number of integers, odd integers, at least 3, that are not greater, not greater than this. Now, what you need to do here is actually how to solve the last part, how to solve numbers not greater than this. You do it, you have to do it. There are multiple ways. You can do it using binary search. You can do it using binary search. Or you can calculate square roots. Let's talk about square roots actually, so because it's sometimes people struggle with square roots. So let's again int n. So I have now again. So what I need to do, I need to find the square root of 2n minus 1. So I need to find square root of n minus 1. So I have floor of 2n minus 1. Let's do it. Let's see. It is max a will be my square of 2n minus 1. What's the problem? Why I write my own square root there? Because no, it's tempting to do something like this: return int of square root of x, and it will probably even work for this problem, but probably not. Okay, for 10 power 9, it will probably just work. If you have some bigger number, then it may actually not work like this. So well, let's try actually. It's programming. It's a programming experimental science. You just try something and see if it works. So let's just try. So I know max a. So let's say if max a is less than 3, then I just sound 0. Else, so I count number of odd numbers. Yes, odd numbers. It means max a minus 1 over 2. Yes, something like this. Let's try. Can I count? Yeah. Let's just submit it. Yes, again, sometimes it's easier to try. Let's see if it works or not. Because maybe I'm explaining you something that already works. Okay, it looks as it just works. Okay. So there's no problem here. What I was trying to do, what I was trying to tell you. So here, so if you have small integers, it looks like it's just work. For integers up to 10 power 9, we have what's the problem here? When you calculate the square root of x, you get floating point number. Yeah. So this problem is not precise. So computer uses floating point operations, yeah, to calculate this number. So there is always some error when calculating floating point number. So this this number is not precisely calculated. So when you try to find this, you may have a little bit. You may, when you transform from this number to integer number, you may have some mistake. For small numbers, it doesn't happen. It makes sense actually, because I have small numbers. Yes. Okay. Square root of 10 power 9 is up to this. Okay. You have enough. Okay. For big number, you may have problem here. So you may want to adjust this number a little bit. Let me say, so if you face some problem like this, there may be more safe way to do it. I would do it like this. So I will calculate number a, then I would say something like while a square, let's say less than x a plus plus, while a square greater than x a minus 1. So I just adjust it a little. Return. So in case I lost some precision here and I missed the number a little bit, I will adjust it here. So it's just more safe way to calculate square root. But yeah, a square tail long. Okay, I don't know C++ well enough. Okay, what is square tail? It produces long double. Okay, long double has enough precision, I believe. Okay, maybe it's enough usually. Okay, I learn something new every day. Okay, maybe if you do just like this, it always works. Maybe I'm just okay. Maybe I just don't need to do it usually. Usually I do it like this just to be safe, but maybe I don't need to. Okay, thank you for your advice. Okay, good. Nice. We have 2 problems left. So problem G is all about implementation. So it actually it's quite clear what's going on in this problem. Yeah. So you have this. You have cell. Every time it grows one position, we need to find the first time when you have c squares. Everything is absolutely clear. The only problem is how to implement this. Again, the problem is you can implement it like this. You just create this square and mark all the positions, but the n is up to 10 power 9. So you have, so the size of this rectangle is like 10 power 9 by 10 power 9. You cannot make the 2-dimensional array of this size, so you need to do something more interesting. And there are multiple ways you can solve this problem actually. For example, what you can do, you can do it like this. Again, let's go to the whiteboard. You can do it like this. You can start by 1 cell. So you start by 1 cell, then you add this part, then you add this part. So every time you increase the size of your romp. So you increase the size of this area by 1. Yeah. Let's call it diamond. So every time you increase the size of this diamond by 1 and just count how many new squares you have. So you have 1, 2, 3, 4, 5, 6, 7, 8. Yeah. You can count this number very fast actually. So you know the size of your border. You just go along your border and calculate how many points you get. So if you know how to calculate this number really fast, then you can just increase the size of your diamond 1 by 1 and check until it have size at least c. Why it will work fast? Because the size of this diamond is actually like square root of the number of coins. So number of squares grows quadratically by the size of this diamond. So number of steps you need to make is like close to square. So if you have diamond of c squares, then the size of this diamond, this size, is about square root of c. Square root of c is not that much. It's 10 power 9. Square root of 10 power 9 is a small number. So you can do it like this. It's one possible way to solve this problem. To implement this solution, you need to do the following. So you have some position here in this one. So you need to look at this border. Let's draw it something like boom, 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 boom. And you need to find a way to calculate number of squares here, 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 here. And you can do it, for example, you look at all these 4 sides. For each side, you calculate the segment of available cells. Yeah, it's always the segment. And just calculate number of squares in this segment. Okay, it's all doable. You can just implement it like this. I believe some of you implemented it like this. Again, and it is correct solution because square root of c is small. In addition, approximation. Why it's about square root of c? No, because the size kind of grows quadratically. I will not prove it formally, but it kind of makes sense. No, again, if you don't have borders, it's kind of trivial. But you have borders that when you have borders, you have problems because sometimes it's, especially in the last case when you have something like this. So here it doesn't grow, so it's actually speed of growing actually decreases, but it doesn't make it that doesn't change anything. Okay, not that important. What is more interesting approach, which actually I suggest to use in problems like this, is no. First of all, let's use binary search. So again, what I want to do, I want to simplify my problem as much as possible. As much as possible. Every time, try. So if you have some complicated problem, try to simplify it before you start trying to implement it. So because even if it looks already simple enough, try to simplify a little bit more. Maybe skip some strange cases. Maybe just reduce some problem. If you reduce one case to another case, you have again one case instead of two cases. You need to implement twice less code. So try to simplify a problem. So what I want to try to simplify it here, first of all, if you have a problem like this, first of all, let's do binary search. So first of all, let's binary search over the size of the, is this a variable for size? Let's call it D. So you have a diamond like this. So let's say this name is D. Let's say binary search over D. Why is it good to make binary search in problems like this? Because it simplifies your problem. So my initial problem was find minimal value of D such that the size is at least T. Yeah? So you try to minimize something. When you apply binary search, you have much easier problem. So now, what we do in binary search? In binary search, we just need to check. So we have value of D, yeah? And we need to check if we have diamond of size D does contain at least C squares or not. Yeah. So we just need to be able to calculate square of particular figures. So we just draw this diamond, calculate how many squares, and we need to check if it is C, if it is at least C or not. Yeah. Again, we simplify the problem. So we start from problem of minimizing something to problem of counting number of squares in diamond. Yeah. Good. Now the simplified problem. Now we see if we actually simplified something. Now, how to calculate? How to? Let's do something. Okay, I want to show you some different approaches. Okay, let's draw something like this. Good enough. Okay, good enough. So I need to calculate the number of squares in this area. Yeah. It's hard to hit such big area. Oh. So I need to calculate number of squares in this area. There are multiple ways to do it. Usually, when you have problems like this, what you want to do, so actually the same approach works in computational geometry. So we don't have any geometry problems today, but it's actually very close to what you have in geometry problems. In geometry problems, when you need to calculate some area of some strange object, what you do is you split your object into some easy polygons. For example, when you calculate area of the polygon, you split this area into some simple polygons. So it's hard to calculate area of this strange polygon. But if we split it into some triangles, yeah. So we just need to calculate area of triangle. Yeah. So if you know how to calculate triangle, you split into triangles, calculate sum of each triangle, calculate sum, you have the total area. Yeah. So that's the basic idea of how to calculate strange areas. And we will kind of try to apply something simpler here. So what you want to do, you wanna, instead of calculating this area of this complicated object, which looks very strange, you wanna split it into some simple objects and then calculate area of each simple object. Multiple ways to do it. Let's discuss them all. For example, again, this approach actually specifically goes from computational geometry. So if you know how to calculate areas of polygons in computational geometry, sometimes we do it like this. We split a polygon into some trapezoids. So we solve myself further. Yes, if you don't want to spoil yourself solution for all problems, you may skip. But again, you already spent a week of solving this. If you still didn't solve the problems, maybe you wanna, it's up to you. So if you don't want to spoil solutions, you can leave at any moment. What else talking about? First, how do we calculate areas in geometry? So what we can do, we can split everything with some vertical lines like this. Now, boom, 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 boom. Now, if you look at every vertical column, yeah, calculate how many squares you have here. So here, so what happens? So you have 1 square, then you have 3 squares, then you have 5 squares, and so on. So in this region, you have 1 square, then 3 squares, then 5 squares, and so on. So in this region, you have some arithmetical progression. Yeah? So if you know it's arithmetical progression, you can calculate number of squares. Just calculate sum of this arithmetical progression. Now here, in this region, you will have another arithmetical progression. Yeah, because you stop growing here, so it will be grow by 1. So we have 1 square here, 1 square here. Yeah. So you have another arithmetical progression in this region, and so on. So in every region, you have some arithmetical progression. So you can just find all this region, it will be just constant number of these regions. And in each region, just calculate some arithmetical progression using standard formula for arithmetical progression. That's one of the way to approach this problem. Okay, that's the method. Okay. Okay. Okay, this method is quite universal. Yeah, this is how actually people calculate areas usually. So they split everything into some trapezoid-like elements and they solve them. Or you can split everything in some like triangles. It also works. Right? Okay, the only trick of this problem is actually to find the borders of these segments when something changes. When something changes, when you start the polygon, or here, when you the leftmost point of your time, when you move here, so let's pick some critical points when the behavior change of this function. So again, my function, if you look at number of squares for each column, you have some arithmetical progressions, or you have some linear functions. If you want to think about functions, yeah, you have some number of linear function, and the number of these segments when you have different linear function is kind of limited. So when this linear function changes, so when you start the polygon here, when you're in the middle, when you're in the end here, also when polygon starts, or when rectangle starts, when rectangle finishes. So I just mark all the critical points here. Now, when you intersect the border of the rectangle, you intersect border here, you intersect border here, you intersect border here, and intersect border here. There will be at most 4 points when you intersect two. Now, you just find all these points, sort them, and then you split everything into segments. You have segment 1, segment 2, 3, 4, 5, 6. And now, inside every segment, you have some arithmetical progression. You just count the sum of this arithmetical progression using standard formula, and you're done. Okay. I prepared and I implemented it beforehand. So I believe this solution does this. Okay. yeah, I believe this solution does exactly this. So let's, instead of writing it from scratch. Yeah, so here I have normal binary search. Yeah. Now calc just calculates the area. So what I do here, I calculate all the critical points, like here. I mark all the points on the border of rectangle, on the border of my diamond. And here, if I intersect the border, I also add the points of intersection. Okay, I just check if it's empty. I believe it's for debug. I believe I was debugging. I sort all these critical points. Now for every critical points, I have this segment. For each segment, I calculate. Oh, here I simply calculate value in the left, value in the right, and apply formula for arithmetic progression. And to calculate value in the left, I have another function which calculates value in the column. Again, maybe it looks overcomplicated, but again, this is some pretty universal type of universal style of solving problems like this. Okay, so there is a lot of code actually. It can be done easier. We'll discuss easier solution, but overall, every part of this code is pretty standard. So I don't do anything special here. I just mark all the points. Put them, calculate everything. Here I apply standard formula for arithmetic progression. Every part is pretty standard, so they have a lot of minus ones here and there. So it's not that great, not that great code style actually. But yeah, if you're careful enough, you can implement something like this. Let's discuss some better solutions actually. What you can do better in this problem? You can find even easier way to calculate this area. An easier way actually to do it like this. So what you can do? Well, first of all, if you don't intersect anything, you just stay in the middle. Then you just calculate area of this square and you find. Yeah, so it's easy. So calculate area if you don't intersect in borders. Now, if you actually intersect some border, if you do it like this, then you take total area of your diamond and subtract this triangle. Again, area of triangle is very simple. You have like 1, then you have 3, then you have 5. The area of triangle is just like n squared, something like this. So if number of this is n, then area is something like n squared. Yeah. So triangles are easy. So if your diamonds stick out of the border, you just subtract this area of sticks out of the border. If you intersect multiple borders, like here, if you intersect here, here, and here, well, let's just subtract all of them. So you calculate total area of diamond, subtract this, subtract this, subtract this. You have something. The trickiest part actually when you have a situation, let's say like this. So when you stick out of the border here and cover some corner like this. That what will happen? I will subtract this triangle and I will subtract this triangle. So this small triangle here will be subtracted twice. But what you do in this case? When you subtract something twice, you just add it back. So you subtract these two triangles and then add back the area of this small triangle. And do the same for all four corners. So the final formula looks like this. I have total area of my diamond minus 4 parts that sticks out of the border and plus 4 parts for each corner. And that's all. It's very simple solution actually. So only thing you need to calculate is area of the diamond. It's just simple formula. You just can find it, and area of the triangle. Again, it's just sum of arithmetical progression. And then solution is really simple. Let me show you. That's the whole solution. Again, just that's all. So this is the area of triangle or of the diamond. Again, I use the same formula as for triangles, because every diamond is just union of two triangles. I split it like this. So I have triangle here of size d minus 1 plus triangle here, d plus 1. So I have d here and d plus 1 here. So total size of the diamond is like this. Then I subtract everything that sticks out of all these triangles. Yeah. And then I have another function sum2 that sums this, because I had a different form. I have triangle like this, yeah, like this, and triangle like this. Just choose different formulas for them. That's all. That's basically the whole solution. Again, what's interesting about this problem? This problem, you don't need any specific knowledge. You just need to carefully implement this and simplify the solution as much as possible. The shorter solution you have, less bugs you have, easier to debug, easier to so that's whole this problem is about simplify your problem to the point when it's easy to implement and easy to debug. Okay, in final problem, you actually need to do something complex. So it's actually a good, difficult problem. So if you solved it, be proud. So what's happening in this problem? We have some strange thing about longest increasing sequences. Like it's just, yeah. So longest increasing sequence is a very popular object in some computational programming at least, or in computational programming at least. So what do we know about longest increasing sequences? So let's check what do you know about. Okay, let's try to ask you actually. So do you know how to find long increasing sequence in square time? So do you know how to find longest increasing sequence in n square time? Can you raise hands or something? How this Zoom works? I never like Zoom. Who knows? Who else? No, you don't know. So again, if you don't know how to do this, you probably need to step back to this problem. So you need to probably go back to dynamic programming and yeah, and cover this topic. So it's very standard dynamic programming topic. So the way you do it is calculating like this. You calculate, you go from left to right. Let's take some. Too boring. Let's see something like let's say 2 1 5 3 6 4. Good enough. Let's do something like this. So what we do, we go from left to right and calculate dynamic programming. Dynamic programming value will be like the di, will be length of maximal longest increasing sequence for numbers from 0 to I. Let's do it inclusive. Yeah. Such that AI is the last element. So I look at the prefix including this element and calculate the longest increasing sequence. So this element is the last element of the increasing sequence. And the way you do it is like this. So again, you look at your element. So this is your element. So A. I'm sorry. So AI. You look at the previous element, J. So you look at all the elements to the left. They are less than my element. So I need to be increasing sequence. And for every this element, I have some increasing sequence. So I can add my element to this increasing sequence and have the sequence of one longer. So if I take this element, my sequence will be dj plus 1. Yeah? And out of all these variants, I pick the maximal one. So di will be maximum of all things for all a j less than ai and j less than I. Yeah. So I take all elements to the left which are smaller than me and calculate maximum of all these values. Let's try to apply it to this array. So this is my array. Let's calculate array D. So I'm gonna go left, right, just apply this formula. Okay, if this is empty, then length is 1. Yeah. If this set is empty. Okay, for first length is 1. Here I have no elements, so length is 1. Here I have two elements, 2 and 1. Both has length 1. So my kind is 1 plus 2, plus 1, 2. Here I have 1 and 1 again, like it's 2. Here I have all elements to the left. Maximum is 2, so it will be 3. Here 4. Again, look at all elements less than 4. There I have 2, 1, and 3. So I have maximum of these 3 values plus 1. So maximum will be 2 plus 1 will be 3. And that's all. That's how you calculate this dynamic programming. And again, this one of the first problems you solve when you study dynamic programming. So if you don't know how to do, just go back and again repeat dynamic programming. Now, why I think about this? Why I think about this? The problem is completely different. I don't need to find longest way. I need to do something completely different. But it looks like my problem is not easier than finding. And again, when you have some object, you need to remember everything you know about this object. Like in this problem, I have longest increasing sequence, so let's remember everything we know about longest increasing sequences. Good. Now, another thing we will need is to do the same thing. So we will need to be able to calculate longest increasing sequences, but in n log n time. That's a little bit more professional thing. So if you don't know how to do it, that's okay. So if you never see something like this in competitions, that's the first time. So congratulations. So how to do it in n log n time? So if we will do all the same tricks, but we will calculate. So what is the trick? We'll calculate this thing in log n time using binary search. You do it like this. Okay, what is easiest thing? Easiest thing is like this. So let's maintain another array. Let's maintain another array and then another array. Let's say, I need to have another lecture about longest increasing sequences. So now it's brief explanation. Okay, so it's not real lecture. So I need to have another normal lecture about this. So how to calculate this value in log n time? You maintain the following thing. Let's maintain another array. Let's say b. B of x will be, so let's look at all sequences of size x. Yeah, I want to find this. So let's look at, so what I'm doing here. I try to add my new element, this ai, to some sequence such that last element is less than me. So let's look at all sequences of size x. Let's find the smallest last element of the sequence of size x. So smallest, let's think. So minimal, let's say minimal last element of sequence look LIS, no, LIS of size x. Now, when we calculate this value di, we need to find the maximal x. Let's rewrite it like this. We need to find maximal x such that p of x is less than our element ai. And add 1 to this value. That's the plan. Yeah. So we find maximal length of the sequence, so we can add our element to this sequence. And the trick is that array B will be sorted, so we can do it using binary search. So let's do it. So again, let's try to repeat this again. So I try array B. So I start by doing the following. Let's do so. So let's say we have sequence of size 0 with last element minus infinity. So we can add anything. And we don't have anything of size A1, 2, 3, and so on. You can put plus infinity here, but doesn't matter. I don't have any sequences of size 1 more. So when I calculate size 2, yeah, I find this plus minus infinity, add my element 2. So now I have sequence of size 1. And now I update this value. So update this value. So here you have 2. Now you have this one. Again, you find the maximal rightmost position in this array B when you can add the element 1. So you can add element 1 after 2, so you can add it after minus infinity. So again, value is 1, you update this value to 1. Now again, here you find the rightmost value, so that is smaller than 5. It's this value. So you can add 5 after 1, so length will be 2, and you update this value here, 5. Again, it's not a lecture, it's just brief explanation of how it works, okay? So if you never saw this before, that's fine. So that's what I want to say. So we need to have separate thing about this. I don't want to explain it perfectly. You actually need to try it and try to write the code. It's what I want to say, that it's possible to calculate this array D in n log n time. So this array D can be calculated at n log n time. If you never saw it before, it's pretty hard to solve this problem. This particular problem actually uses this a lot. But okay, let's skip this part. So if you don't know how to calculate this array D in n log n time, you need to learn how to do it. Not today. It's only the part of this problem, and actually easy part. You need to think what to do next. So imagine you calculated this array D. You know how to calculate it in n log n time. What to do next? The problem is actually different. You need to first calculate for each element if it belongs to at least one longest increasing sequence, and check if it belongs to every longest increasing sequence. Let's start from the first one. So let's take any element x in the middle. So let's say element AI. How to check if element belongs to longest increasing sequence? No, let's find the longest increasing sequence that contains this element. So if I have my element, I want to find the longest increasing sequence. So what I need to do? I need to find some elements to the left that forms increasing sequence. So this is less than this, this and this, this and this. So I find some elements here. And I need some find elements here. Let's have two elements here. For example, I have 3 elements to the left and 2 elements to the right. Yeah. So I can form a sequence of size 6. So this first problem, counting this element, is just the same problem of we did before. So it's like d of I. Now, d of I is length of this sequence. Now, let's put like this. Yeah. Now, problem to the right is actually a symmetrical problem. It can be solved absolutely the same way. We just reverse the array, invert all the numbers, and we have the same problem. So we do the same thing from right to left, and we calculate this sequence. Let's say D2. Yeah. So now the maximal sequence that contains element I will be di plus d2 of I and minus 1, because we counted this element twice. So this is the length of maximal sequence which contains element I. So now I just need to check if this number is equal to maximal longest increasing sequence, to the longest increasing sequence. Да? So di. Yeah. So we'll calculate dynamic programming, calculate it again backwards, and check if element may belong to any increasing sequence. That's how you check if your element belongs to any increasing sequence, longest increasing sequence. Yeah. Now, how to check if element belongs to all possible increasing sequences? That's a little bit more complicated. Let's see. To check if element belongs to all increasing sequence, we actually need to look closer at these numbers. So let's go back at these numbers. One, two. If we have index integers, we'll have vacuums. Yes, something like this. So let's look at these numbers. What they actually tell you. These numbers actually tells you what is your position in this longest increasing sequence. Yeah. So for example, here I have longest increasing sequence 3 elements to the left, 2 elements to the right. It means that my element belongs to some increasing sequence of size 6. Yeah. And my element is always on the 4th position. So I have some 3 elements here, then element AI, then some 2 elements here. So there may be several different ways to pick these 3 elements or these 2 elements. But I always have 3 elements here, always 2 elements here, because my sequence is maximal possible size. Yeah. So in every longest increasing sequence, my element AI will be on the 4th position. Yeah. Now, to check if element belong to all longest increasing sequences, we just need to check if this position only may be used by this element. So for every position, we remember how many elements we have that tries to have this position. If there's only one element for the position, then this element should be in this position in all longest increasing sequences. Yes. Bug implementation. Ooh, do we have time? We not have. Let's try to find bug in this solution. Okay, let's first read some correct solution. Okay, who was the fastest solution? Okay, that's the fastest solution for this problem. Let's read it. Okay. PovMod. Why you need PovMod? You could. No. So why? Okay, you don't use this PovMod. Okay, just do it, but you don't use it. No, let's read it. So what we have. Okay, that's here's too long. Okay. So to read data. Okay, this is your binary search when you calculate. Yes. So this is okay. This is the standard part when you calculate dynamic programming for longest increasing sequence. This is how you do it. Okay, why not? Here you just do it again. Okay, why? You do the same right to left. Okay. It's just better if you do the same thing twice. Just move it to the function and just call this function twice. Because if you have bug in one implementation, then you copy this bug twice. It will be madness to find this bug. So try not to do it. And if you make changes, you need to make changes in 2 places. Here you find the maximum possible. Okay, you can do it like this. Why not? For every pair, you calculate number if you face this pair. Also possible. You only care about pairs that with sum equals to longest grid, but okay. Now if length is less than maximum, yes. No, and yes, if count is greater than 1, it means it's not unique, so it's 2. Good. Yes. I didn't submit. Okay. Okay, so thank you for listening. See you next week. If you have any questions, again, ask them in Discord. Okay, bye.